Okay, Assalamu alaikum again and good afternoon, everybody. Thank you very much, Abdulaziz, for the introduction. This presentation is going to be co-presented by me and my colleague AlHawaj, and we are focusing on a very important subject of plant reliability. And as we know, rotating equipment plays a major role in unreliability, actually. Many times the plant could have unplanned shutdown because of a compressor or of a critical pump. And in order to avoid these unplanned shutdowns, we have the VMS, which is vibration monitoring systems, whose objective is to protect the equipment from unnecessary damage, and also in order to help diagnose the problems. So in our presentation here, we are going to explain the balance that is required for the plant people either during operation phase or during the project development for new assets in order to have the required balance between protecting the asset from damage and unnecessarily having shutdown. So if the equipment is at risk of damage, we are going to shut it down, but sometimes there is a way to avoid the shutdown while keeping the machine running. So in order to do that, we are going to go through some configurations, and these configurations are shown in the next slide here. So we are going to have the foundation that is necessary for all of us, and this foundation is basically the overall components that comprise the VMS system and the outcomes that we expect from the system. Then we will go to the core of the presentation, which is the configurations. We'll go through 6 items in the configurations. These are related to time delay and trip multiplier, which are very important for the machines, especially during startup of these machines. Then we are going to go to the rest of the configurations. During the presentations, inshallah, we are going to have some cases either embedded within the slides or at the end of the presentation. The importance of the content here is that it is a gray area between people who are specialized in rotating equipment and people who are specialized in instrumentation and controls. Many times the configurations are usually configured, the configuration parameters are done by the instrumentation people, and eventually the equipment and the protection system is handed over to the rotating equipment professionals. And that's why some of the configurations could be misunderstood, and understanding the configurations will help a lot in making sure that the equipment is diagnosed correctly and promptly. Otherwise, we may have unnecessary downtime during the data collection. So let's jump to the configurations and the components of the system. So this is a typical circuit for an online system. So in this left side here, we have the bearing, and on the bearing, we have the vibration probe that is measuring the vibration of the shaft, and we have the classic circuit all the way to the monitor. And the monitor's objective is to give the reading of the vibration. For example, if the reading is above the danger level, the machine is going to be shut down by the ESD, by the emergency shutdown system. And if the vibration is acceptable, the data is going to be continuously collected and it will be sent for diagnosis, for condition evaluation and monitoring. So the configurations are actually conducted at the rack itself, which is this box here. It's basically an intelligent card that contains some logics and some communications between the field instruments, the vibration probe, and the emergency shutdown system or the rest of the plant. And when we talk about configurations, we usually talk about some data sheets that are currently edited by laptop. In the past, they were edited by jumpers and other connections. So these are the outcomes we usually have from the online vibration system. So if assume we have a compressor, for example, in the compressor, we are going to have bearings, and in the bearing, we could have some measurements for the bearing temperatures, or maybe we have axial position measurements And the last part is the vibration part, which is the core of our presentation. So if we focus on the vibration and we take only one vibration probe, for example, the X vibration probe, so in that case, we are going to have many parameters, and the configurations we are talking about today in this presentation are most of it are focused on the vibration probe for for focus on the vibration configuration for one probe. And as you can see, there are direct readings, which is basically the overall. We could have waveforms, we could have some spectra, and each one of these have its own configurations. So this is one screen. This is just a typical screen from one of the points, and in this particular screen, we have the limits for the gap voltage. So each circuit, in order to make sure it is healthy and giving you the correct reading, there are limits called the limits, OK limits, and in this particular case, we have upper limit or lower limit. Also, we have the polarity, which is an indication of the movement of the shaft towards the probe or away from the probe. This part is very important for axial positions. And if we go for next steps, we have more and more configurations. Actually, this could be overwhelming for people who are not familiar with the type of details. But in our presentation today, we are going to focus on only the most important 6 parameters that are related to the configuration, the parameters that are important for most of the people in the plants. So for us, in order to simplify this, we can say the configurations are done at different places. So we have configurations that are done on the hardware, on the rack, on the vibration monitors, and these configurations are usually related to protection. So we can have there the set points for alarm and shutdown. We have things related to data collection. How fast is the data collected? How frequent the data is collected in one day, for example. So this one group, one category of configurations. The second category of configurations is not really meant for protection. It is meant for diagnosis in order to troubleshoot if there is a problem. And these configurations are in the software of the analysis. So if you are interested to see the spectrum, for example, you need to set the parameter for the spectrum or the parameters for other related plots. You can see them in the software related to the analysis. But we have one more group of configurations that is even outside the hardware and software of VMS. It is the plant system. So for example, we have configurations that interact with the VMS from outside. For example, we have the ESD. So sometimes we have configuration that is on the top of VMS. For example, if you have time delay, if you have a time delay, the time delay on high condition of a machine is governed by the rack itself. In addition to the ESD, you could have a time delay in the ESD. And you can have another time delay in the rack. Or in a third situation, you can have both of them together. So these details are important for you as a rotating equipment or as a plant engineer, plant professional, in order to understand why the trip took place, why it took place in this manner. And if you have an equipment that could behave in a certain way, you should design your protection system, your configurations to be, again, a balance between overprotection and underprotection. So in order to explain more about the time delay and the trip multiplier, which is associated also with the protection, especially during the startup, I will hand over the presentation now to my colleague, Mr. Ali Al-Hawaj, and I would ask him first if he has any comments on the slides I covered, then he's going to take over. Please go ahead, Ali.
Yeah, thank you, Ali. Just to start with, I mean, if you can just go back to the previous slide. Again, as Ali mentioned, that this configuration will basically take an action and show exactly what is the required outcome of that. So if you can see, there are the configuration for example, the trip set points, which are configured in the rack hardware. And then you have the the time delay, which is actually configured again in the rack hardware. But when we go to the triggering the trip multiply, you can see that it's configured in the basically external hardware. So that will trigger something that is configured in the rack. If any of those are not configured correctly, that means that the whole system will not work as expected. Now, when we go to the next slide, we are talking basically about one of those parameters, which is the trip time delay. Now, just to make clear, now the trip time delay is basically a time that is configured for the signal to be triggered when the set point is achieved. If you see those trends in the screen, you can see that there are yellow and red. The yellow one will show the alerts, basically. The red one will show the danger. Normally, those danger will trigger the relay to trip the machine. So we have here multiple examples that can show different cases for different configuration. And this will give you an idea about how changing those configuration or misconfiguring the system can lead to different outcome. So in case number A, you can see that there is no protection configured. And that means that when the variable is actually exceeding the danger, the red line, there will be no trip happening because there is nothing configured, no set points or no trip configured on that trend. Now, when we go to B, you can see that actually there is a trip configured, but with a time delay of 3 seconds, which means basically that the machine will trip after 3 seconds of the channel or the variable passing the red line. In total, that's a 4.5 seconds from the actually starting up of the machine. Now, when we go to C, we can see that there is some other variable configured, which is the startup time delay, and that's going to be 5 seconds. So after 5 seconds of the machine starting up, there will be more 3 seconds because of the time delay configured for the trip to happen, which will cause 8 seconds in total to have that machine tripped. Now, we have 2 more examples here. So example D is basically when we have a startup configured as a time delay, but we don't have any time delay on the channel itself. So as you can see, the machine actually started very high and then goes slowly after 8 seconds until it starts to be normal again. And here we'll have no trip at all. And when example E basically shows a different configuration where we have the startup is at 8 seconds, but we have a time delay on the rack for 3 seconds. So you can see that when the machine starts smoothly and then exceed that line, the red line, it will trip after 3 seconds, which will give us 12.5 second configuration. Now just to show here something, like basically when we see here as a startup for one of the machines, we can see that the machine is actually starting up and then going up there, and then it goes down with the normal trend, which is below the alert and danger, but it will not trip because the configuration was done correctly. Now, just from the feedback or from the actually from the history, I can tell that having those time delays configured correctly will be actually very crucial for the machine to run, because when we have a very short time delay or a very long time delay, that's going to affect the basically operation of that machine. And sometimes it will even prevent that machine from starting up. So another factor here is basically the trip multiply, which is going to be the next slide. Now for the trip multiplier, it's basically a configuration that can be done on the rack itself, on the vibration monitoring system, to basically multiply the set points, which are the yellow and red line we just saw there, by 1.5 or more till 3 times, to make sure that when the machine is starting up, there will be no trip happening at that time. The problem is here is that this will be triggered from an external system. So that means that you need to make sure that the external system, in such cases DCS, will basically enable that and close it as, and basically enable, trigger it, and also disable it after that specific time. Otherwise, you will end up with a machine with actually 3 times the trip, the alarms configured the whole time while the machine is running. So we can see here that this trip multiply, which is actually coming as 1 in the default configuration, that need to be changed as per the machine itself. Now, when we go to the time delay, you can see them in the green box down below. Sorry, Ali, just for that. Yeah. So we have them below here. It will show that normally we have danger with a time delay of 1 second. Danger is the red line basically, or the trip signal normally, and then the alert with a 3 second configured as a default. Now, the next slide will actually show some examples here. So if you can see, case 1 is basically when the machine is having a 3 second configuration for the danger. And that means that starting when the machine started, it will have 3.5 in total because of the 0.5 second when the channel is actually exceeding the danger. And in total, that's going to be 3.5 seconds. The other case is basically when you have a startup configured, and that will again increase the 5 seconds plus the 3 seconds. So you will have 8 seconds in total to trip. But the third case is showing actually a trip multiply configured to be 3 times the set points on the first 15 seconds of the machine running. And that means that after 15 seconds, you can see that already the signal is again coming under the danger line. And that means that the machine will not have any trip caused because of that. So it's very important to make sure that these configurations are done correctly. Now, just to give some information about what can go wrong here is that sometimes those trip multipliers are configured once on the whole rack or the VMS system. But this VMS system is actually having different machines, let's say 3 machines or 2 machines. In that case, then we need to make sure that they are actually segregated into multiple trip multiplies. Each of those will be configured to be triggered in a different way to avoid having wrong trip multiply running on that specific case. So this is very important to make sure. And those trip multipliers can be configured again, either through hardware signals or through software signals. Again, when these normally are going to be carried on during the commissioning stage of each project, and also can be optimized later on. So back to you, Ali.
Yes, thank you very much. Thank you, Ali. One more comment I'd like to mention here before I move forward. Sometimes operations report that they receive a trip signal without having an alarm signal. And one of the common reasons for this is that the time delay for the trip signal is very short compared to the time delay for the alarm signal. So if you have a case from operations complaining that they have trip without alarm, you need to go back and review your time delays. Okay, thank you, Ali. One more time, let me proceed with the third configuration, and it is called latching and non-latching. So basically, latching and non-latching is related to keeping the alarm standing after the value of the vibration drops below the limit. So assume you have a vibration that is above the set point for a while. The set point is 5 and the reading is 7. Then gradually the reading drops below 7. If the alarm will continue there until somebody will manually reset, it is going to be called latching. And this latching is very important to keep an eye on the critical alarms. So if you, for example, want to the operator or the field maintenance to check the machine on site before anybody restarts the equipment, you may need to consider having it as latching. This is a statistics based on a survey from LinkedIn. 80 people from my network had cast their vote, and they said they are using latching for danger relay output. So if they have a shutdown from their VMS, usually they have latching configuration. And this is an example explaining what I have just said a while ago. So if you have the reading for the vibration dropping below the alarm set point and there is no latching, the alarm by itself, it will clear. But if you go to the danger level and it is latching, even if after the reading goes to 0, for example, or very low, the alarm will not clear by itself. You need to have somebody manually to clear that from either the VMS or the DCS. And these are some details that are related to the relay outputs. These are going to be available in the presentation after we finish the conference. I collected them just for your quick reference in order to make the review easier for you if you are interested. This is API 670. This is one of the most important standards used for configuring the racks. So this is the screen of the VMS, one of the products for VMS. This is the way it is configured. And again, there is an alarm configuration and a danger configuration. The way we are going to do the remaining slides, we are going to explain the concept, and we are also going to show you a sample of the configuration screens just to have a flavor of how to configure it. We finished latching and non-latching. We will go to another parameter called synchronous and asynchronous. And this configuration is more related to diagnostics. It is more related to interpreting the plots of the high vibration. So this is used usually in order to determine if the high components are available or not in the spectrum. So if you are interested to see high frequencies because you have a doubt, maybe you have a defect on high frequencies and you need to adjust your Fmax, the maximum frequency range in the spectrum, you may need to review the configurations of synchronous and asynchronous. So basically, synchronous means it is associated with the speed of the equipment. Every time the speed changes, the Fmax of the spectrum, the width, the bandwidth covered by the spectrum is going to change. If the speed increases, then the frequency is going to increase to cover more and more frequencies. This is opposite to asynchronous. Asynchronous spectrum or asynchronous waveform is independent of the speed. So you are going to have fixed frequency spectrum. We are going to have fixed span. Every time you start up the machine or shut it down, you increase the speed or you reduce it. For diagnostic purposes, I encourage the people who are involved in vibration analysis to use both of these types of waveforms in order to have the complete picture. These are some examples now. So this is, again, the summary of the differences between them. Primarily, you need to have a key phaser in order to have synchronous, and no need for a key phaser for the synchronous. And Fmax is going to be changing in the first one while it is fixed in the second one. So for example, here, these are two waveforms collected from the five, which is voting. And basically voting here is important for reliability in order to avoid unnecessary trips, especially if you have a doubt about possible spikes. So you don't want to shut down a large facility because a compressor has a trip on a faulty signal. And one way to avoid or reduce the risk of unnecessary trips is to have a check from the sister probe. So if you have one probe reading very high, while the second probe, which is next to it, is reading very normal, most likely this spike is not realistic. It's not mechanical. Maybe it's grounding issue in the circuit. Maybe it is a loose connection, things like this. And again, we have a vote here from LinkedIn. And according to the result of the vote, the majority of the people are using double voting. So they are using X and Y probes on the same bearing. They need to show high, in the same time in order to initiate the trip. If only one of them, it's not going to be a trip signal. And in this slide, we see the difference. And if you go to the literature, you have different terminologies used for voting. Some is called 1 out of 2. This is called single voting. Sometimes they write it in this way, 1002. Sometimes it is called OR gate, in opposite for AND gate. So double voting is more reliable plant, but more risk on the equipment. So the protection will continue, and the probability of continuing protection is high, but the risk on the equipment is more also. And again, which one of these is your preferred configuration? It depends on the reliability of the system. It depends on your tolerance to shut down the equipment. So this is another presentation for double and single voting. So you need to have each signal of these to initiate danger in order to have an action. In the case of AND, any one of these is going to be initiated. If you are going to have single voting, one of them is enough. So in the danger, both of them, they need to have voting in the case of double in order to shut down the equipment. Another explanation is on this slide. So for example, here on the Y probe, the Y probe triggered the high. It triggered the shutdown set point. However, the X probe on the right side here, it did not. So if you have this case and you have single voting, the result is going to be shut down. But if you have this case with double voting, case number 1, there is the shutdown is not going to be activated, because in the double voting, we need to have both X probe and Y probe. They confirm with each other that it is very high vibration, which is the case in the lower uh, row here. In this row here, in this case, both double voting and single voter are going to shut down the equipment, because both of probes A and B, X and Y, they say it is very high vibration. So again, based on your condition, you need to design the configuration suitable for your plant. So these are common applications of voting, and we already explained them. Sometimes it is used for axial probe, sometimes it is used for temperature elements, sometimes it's used for the radial vibration transducers. And again, we have some literature for you. This is an extract from API 670 for your quick reference. If you don't have an access to the original document, hopefully this is going to help you.
We have 10 minutes, gentlemen.
Yes, thank you very much, Abdulaziz. We are going to cover in less than 10 minutes, inshallah. So
we need also to take some questions. And you have 5 minutes, please, to complete.
Oh, sure. Thank you very much. So now we have the last 2 configurations, which are going to be covered by my colleague Ali Hawaj. Ali, the floor is yours. Please comment if you have any comments on the previous slides.
So thank you, Ali. Yeah, I think you covered it very well for the previous ones. Now, those other configurations are actually based on what you were mentioning before. Now, here we're talking about basically the relay module configuration, and that's very important or very crucial when we're talking about how those relays are activated. So in this slide, for example, show you just a general view for that configuration application that configure the VMS system. And you can see that we can configure basically multiple channels on the same trip multiplier. So at the top, you can see that there is, like, for example, this is channel 1, or let's say the first relay. And this is going to be a latching relay for the logic below it. In this case, you can have like multiple channels with different logics to provide you that, let's say, trip signal or relay signal, which will be delivered to other system. Now, why latching is very important as well is basically because latching will tell you exactly where is that, let's say, trip came from. Because when you have this configured, the relay will be latching, but as well that the channel itself, when it reached to the danger set point, it will keep latching as well. So when you go to the rack or the VMS system itself, you can see exactly like, okay, the relay is activated, and this is the reason why this is activated, because of this channel. This is why this configuration is very important. In some cases, these configurations will be done here, and in other cases, it will be requested that, for example, we have all these channels one-to-one. So basically, each signal will have one relay, and then everything, all the logics will be configured in the ESD system as well. So if you go to the next slide, Ali, here it shows, like, for example, we have alarm number 1, 2, and 3. All of them are going under the same tag to the DCS. So basically, when you see the alarm in the DCS, you will not tell exactly where that came from, like what is the real reason for that trip. And in those cases, latching will be very important for to at least get an idea, or to ease of troubleshooting and knowing exactly where this issue came from. Back to you, Ali.
Yes, thank you very much, Ali. So I will conclude by having one short case study. This is a large machine that was under commissioning, and during this case, the VMS was not fully commissioned, and we were requested to have data collected by portable data collectors. And this machine was running at very low speed. It is around 360 RPM. It's around, let me see, it is around 360. It's around 6 hertz, I guess. And we had the contractor taking the vibration measurements. We took the vibration measurements, and we have a debate. The manufacturer or the vendor representative, the contractor, he says this is acceptable. We said it's not acceptable, it is very high. And this is the difference between our measurements and his measurements. The online system was reading 8 mils, it was full scale, but it was not commissioned. And he said, do not rely on the rack, it's not yet commissioned. His measurement was 2 mils, our measurements was 12 mils. You can see the big difference between ours and his difference. And again, the contractor complained we cannot use our own measurements because our data collector was out of calibration just last week or last month. It was just recently went out of calibration. We investigated the case, and it turns to be, this is his device, this is our device. And if you can notice, his device is limited to read from 10 hertz all the way to 1000. Our device is much wider span. And if you remember, the speed was around 6 hertz, while his measurement tool, this tool here, is able only to measure from 10 hertz. So again, this is related to the configuration and capability of your system. Make sure when you put an instrument, this instrument is configured and is able to detect the vibration of interest. So this is the configuration screen where you can see the minimum frequency and maximum frequency. And with this, actually, we come up to the end of the presentation. So in summary, the configurations are very important to appropriately protect the equipment and avoid overprotection, because if you overprotect it, you will go to unnecessary trips. The configurations we discussed here are 6, and we explained them in print screens of the configuration software, and we mentioned a few case studies. Ustad Abdulaziz,